Hello everyone. So, our today's topic of discussion is peeling testing and abrasion testing. These two parameters are extremely important as far as fabric use is concerned, and peeling is very important mainly for apparel type of fabric, apparel use, and abrasion is both for apparel and the industrial application. So, peeling is related with the actually the look of the fabric, the appearance of the fabric. Okay. First we will discuss the all the aspects related to peeling, and after peeling then we will start the abrasion, although this abrasion and peeling they are interlinked. So, what is peeling? So, it is a fabric surface fault, okay, characterized by little peels of entangled fibers clinging to the cloth surface and which is giving garment unsightly appearance. So, it is a ugly appearance it gives. So, we must actually emphasize the term, it is a little peels and entangled fibers. So, fibers are actually the peeling starts with the fiber entanglement, okay, and formed by rubbing action on loose fibers which are present on the fabric surface. Now, let us first try to understand the concept of peeling. Now, this is one fabric surface, okay. It has say yarns. So, this is a fabric surface with the made of surface yarn. Okay. Now, the peel, suppose one small hair is projected here, one hair is projected here, and due to the rubbing action of fabric surface, this side is a surface fabric, and there will be some rolling of the fiber. It will form a small peel, small, which may not be visible. Now, due to the rubbing action with other surface, it will say it will apply certain force on this fiber, and this force will create some rolling action of the this ball formation, this end. At this end will, suppose the force is acting on this tangentially on this surface. So, there will be one rolling action of this ball along the surface, this is along this surface. So, there is a rolling action. So, this rolling action will create the other end, suppose this is a and this is the other end of fiber, and when this force is, and this is the fabric surface, when this force is applied here, the rubbing force, there will be one torque generated here, which will actually result, which will try to pull this other fiber from other end. Once this yarn, this other end fiber, which is actually inside a yarn, this is yarn. This yarn, if the yarn is loose twisted, loose structure, then this fiber will have easy way, easy path to come out and join with this rolling action. That means, a very small minute roll initially is created, and due to the repeated rubbing action, this is actually rolling, and then this yarn and the other end, from the other end fibers are coming out and the peels are becoming larger and larger, and this is the mechanism of peeling, and that is resulted by many factors. First is that, one is that if the yarn structure is loose, then it is allowing the fiber to come out and form peel. So, what we can do? We can increase the twist, we can make the yarn compact. Then what will happen? This will, if yarn is very compact, this will not allow the fiber to come out smoothly, easily. That means, one yarn, two fabrics, one fabric is made of yarn with high twist, another is made of low twist. So, yarn made of with low twist will have high peeling resistance, peeling tendency. So, that means, if we have yarn, if we have fabric made of a loose twisted, low twisted yarn, that will create high actual level of peels. So, that normally in winter cloth we have seen, which actually resulted high peelings due to the loose structure of yarn. Second, this is the twist. Second, suppose we have two yarns made of two different fibers. One is, suppose this is a two yarns, this yarn is made of coarse fiber, coarser fiber, another yarn which is made of fine yarn, fine fiber, same very fine fiber. Now, the thing is that the flexural rigidity of this fiber is much less than this one, coarser one. So, this fiber will have tendency to form, to bend and form loop. It will form, it will easily get rolled, but this fiber will not roll easily. So, that means, if it does not roll, that means this phenomena will not take place. So, here as it is not forming the ball, although this will create hairs, okay, but the fiber with lower bending rigidity will create the peels. That is why in a cotton, if there is a immature cotton, that will result the peeling tendency. Okay. So, we can use two fibers, one is coarse fiber, fabric made of coarse fiber will actually have less peeling tendency than the fabric made of fine fiber, that is due to the bending rigidity of the fiber. Okay. This is the reason. Another case, we must have observed that the fabric made of pure wool, 100% wool, has less tendency of peeling than the fabric made of wool blended or maybe 100% acrylic. So, the reason is behind is that the wool has got less bending in strength, that is lateral strength of wool is less than say polyester or acrylic. So, what is lateral strength? That means, it is a wool is little bit brittle in nature. So, if it bends, wool breaks, the lateral strength, but for synthetic fibers the lateral strength is very high. So, the problem is that in wool, in case of wool, once it is folding, suppose it somehow it is folding in the initial stage, due to less bending strength, okay, lateral strength, this will actually break and get separated from the structure. Although peel formation may be there, it has already initiated, but this even at the initial stage, due to the rubbing action, this will actually form and still it will break and it will get separated from the structure surface. So, the fabric will look little bit cleaner structure, but once we use polyester or say acrylic blended with wool, what will happen? Whatever the things we are forming, formation is there, even if it is the formation by wool, the acrylic portion of the fiber or polyester portion of the fiber will actually try to hold this peel. Because of the high strength or high bending strength or high lateral strength, this fiber or even tensile strength, it has got high extensibility and high tensile strength. So, polyester will try to hold back the peels and it will actually stick to the surface of the fabric. So, once we blend wool with the synthetic fiber or we use 100% synthetic fiber, it actually creates the peels. So, peel formation, there are various reasons. So, one is the twist, low twisted fabric will have higher peeling tendency, fabric made of finer fiber will have higher peeling tendency, and fabric made of high strength fiber will have higher peeling tendency. Now, there are some man-made fibers which have been developed with low breaking strength, lower lateral strength, and this like polyester during polyester manufacturing, what has been done, the molecular structure has been distorted, the changed in such a fashion the lateral strength of the fabric is reduced, lateral strength of the fiber has been reduced, the fiber has been made little bit brittle. So, that is why this type of polyester fiber is called low peel polyester. So, it is available in market as low peel polyester. So, if we make fabric polyester made of polyester blend or prepare fabric from this type of fiber, the tendency of peeling will be less, because as the peel formation is initiated, this will immediately break and it will get separated. That is why what we have observed that cotton 100% cotton peeling tendency is not that high. If we prepare a cotton cloth with high twist, relatively high twist, so peeling tendency can be controlled, but with the low twisted fabric yarn, the peeling tendency will be high. Okay. So, it is formed by rubbing action on loose fiber which are present on the fabric surface. Stronger fiber component in the blend aggravate its seriousness. Okay. So, these are the peels which are visible in the on the surface, which are attached with the fabric. Okay. So, higher breaking strength and lower bending stiffness results more peel. As I have mentioned, lower bending stiffness comes from say maybe finer fiber. Okay. So, that will and higher bending breaking strength, low twist factor, high hairiness, definitely the peeling is initiated from higher hairiness, and loose fabric structure, results easy and larger peels. So, like knitwear made of loose low twist factor yarn. Peeling is mainly due to the fibers with very high lateral strength, as I have just mentioned, or bending strength or low brittleness. So, if we increase the brittleness, then we can improve the peeling peeling behavior, improve it. So, peeling tendency will be reduced. So, a high lateral strength may be advantageous in some application like technical textiles or floor covering, but for as far as peeling tendency is concerned, the peeling tendency actually increases. So, in apparel sector, low lateral strength is preferable, particularly knitted goods. So, as I have mentioned, the low peel polyester is available. Polyester fibers are deliberately made brittle for use in knitted product, okay, to avoid peeling. So, for knitting industry, low peel polyester is actually nowadays used. So, it is called anti peeling type. Peels do not form where fibers with low lateral strength is there, like wool, anti peel man made fibers. Okay. They can be easily scrubbed off. So, peeling, if peeling still forms, so they can be easily removed, but fibers with high lateral strength will have higher peeling tendency. They will try to actually hold the peeling back on the surface of fabric. And peeling resistance and durability are inversely related. That means, if we want durability in the fabric, then peeling resistance will be low. So, that means that will form peeling due to the high lateral strength. Okay. Now, as far as measurement is concerned, there are two types of measurement. One is objective measurement, which we can actually take the value, get the actually numerical value. Another is subjective measurement. Like objective measurement is that, so in the on the surface we can simply count the number of peels and we can convert, say, per square meter number of peels we can just count, or we can remove the peels and take the mass. So, in these two ways we can express the peeling, but the main problem of this methods are that it is a time consuming and it also does not take care of actual degree of color contrast, which is very important. Suppose a dark shade black color cloth with black smaller peels will be maybe acceptable, but if color contrast is there, that severity we cannot actually judge by measuring the number of peels or mass of peels. So, if we actually, if two fabrics with same number of peels, in one of the fabrics maybe it may be totally objectionable because of the color contrast. So, it does not take color contrast. So, and due to the fact it takes, it is a very time consuming. So, this type of method, this method is not in use, it is not popular. So, subjective method is popular and it does not take manual work too much, it does not take that much time, although the some of the test may take longer time, but the instrument can be started and no monitoring is required during the process. So, by comparing with either the standard sample or with the photograph or by use of any written scale, we can actually compare the severity of the peeling. Okay. That is a subjective. Now, there are standard grades. Okay. So, here grading starts from say 5 the 5 grade 1 to 5, 5 means there is no change after rubbing, there is no change, no peel formation. Grade 4 it is slight actually surface fuzziness, okay. Small peeling partially it is formed, that is grade 4. Grade 3 is moderate surface, grade 4, 5, grade 2 is the distinctly there will be peel formation, and grade 5 is actually rejectable, it is a severe peeling is there. So, in this way it is a standard, we can compare with the standard photograph and grade the fabric after certain cycle of rubbing. So, there are methods, one is the ICI peeling box, then random tumbling peeling test, and another instrument which is actually used in Martindale abrasion tester. This abrasion tester it is used for abrasion as well as peeling. Okay. In the same method we can actually judge the fabric for peeling performance. So, in ICI peeling box it is a simple, there are 2 boxes with cork lining. Okay. So, this is the 4 specimens are placed with the size actually that these specimens are cut with the size 125 millimeter by 125 millimeter square, and then it is a form the 2 for warp and 2 for weft, and stitched the face to face and then turn inside out, so that face comes out. Okay. And then fabric the roll it has become tubular and it is inserted through a tube, rubber tube. The loose ends are taped with the PVC tape like this. This is a fabric sample and here is a PVC tape, and this type of the loose ends are actually sealed with the PVC tape, and these are placed on this ICI peeling box, where all 4 samples are taken the tumbled together in a cork lined box. Okay. This is a cork lined box and allowed for certain revolution of time. So, it actually takes certain number of revolutions. So, that is how this instrument goes. So, we can allow it to rotate for certain time, and the specimens are then taken out and removed from rubber tube and then rated. So, rubber tubes then after taking out the specimen, then rubber tubes are taken, then stitched are removed and flattened fabric sample is rated with the using the standard photograph. Okay. Next is that random tumbling peeling test. So, this is actually there will be a random tumbling motion is produced, which is actually simulating the our normal washing machine or normal application, okay, produced by tumbling the specimen in a cylindrical test chamber lined with mild abrasive material, some cork type, some mild abrasive material is there. So, that it will actually this sample will be rubbed against that this lining along with some actually lint, cotton lint, it just to simulate the peeling in actual application. Okay. To resemble the peeling to those in actual wear, small amount of cotton lints are added in the tumbling tester. 3 specimens of 105 by 105 millimeter are cut at an angle of 45 degree with the warp side, okay, and the edges are sealed with the rubber adhesive. So, that the threads are not coming out, okay, and these are the random tumbler, and after that all these samples along with the cotton lints are tumbled in the test chamber. After certain time the fabric samples are assessed. Okay. The number and the timing of the cycles depend on the type of fabric being tested and would be laid down in the relevant specimen. So, for different types of fabric, our number of cycles or timing are different. Say, so for compact type fabric we may require higher tumbling cycle, for loose fabric, for knitted fabric we may require less number of tumbling cycle. Another method is that it is a Martindale abrasion tester, where the specimens are mounted on a large bottom and small top specimen holder. Here the thing is that in Martindale abrasion tester, where we use one abradant, standard abradant surface in the bottom normally. Okay. But here in that small modification is there, here the both bottom and top specimen holder the same fabrics are tested. So, the same fabric specimens are tested and they are actually rubbed against each other. So, same fabric, test fabrics are there, the rubbed against each other, this same sample, and two pressures are used, 2.5 centinewton per centimeter, and another is for knitted fabric we require low pressure, and for woven fabric we require higher pressure, because knitted fabrics are loose in structure. Okay. These are the specimens, this is the sample, another fabric is here, they are rubbing in each other, and in place of standard abradant, as in case of rubbing test, as I have mentioned, the fabric specimen is placed in lower holder. In rubbing test we will see the standard abradants are used. Now, the same fabrics are tested. So, ideally there should be the peeling should be same for both the fabrics. If the degree of peeling is different in upper and lower, in that case only the upper specimen is assessed, not the lower specimen, otherwise we can assess any of these two. Now, our next part is that it is a abrasion testing. Now, abrasion is the rubbing away of the component fibers or yarn. So, it actually when we abrade, the fibers come out from the surface and ultimately the yarn breaks. So, the rubbing away of the fibers and yarns of the fabrics. Okay. So, that during abrasion it comes out. So, abrasion, there are three types of abrasion. One is flat abrasion, like if we take this fabric, this is a fabric and we are abrading with certain abradant, this is called flat abrasion. Okay. Another is called, it is a flex abrasion, the plane, this is plane or flat abrasion. Another is edge abrasion. So, like in the we form one edge of the fabric and then we abrade, we can abrade. So, kind of abrasion we can see normally in the collar or cuff or any fold, this type of abrasion takes place, this simulates this type of situation. So, it has been observed that plain abrasion, the abrasion strength is very high, but at edge abrasion, as the edge at the edge the surface area is small. So, the effective pressure on the fabric is high. So, that means that at the edge the abrasion strength is much lower. So, the fabric the abrade very quickly at the edge of the fabric. Another is flex abrasion. So, it is by flexing and blending, like so this is the fabric and this is abraded in this fashion by bending and flexing. So, when the abrasion is in this type of abrasion is then it has actually abrasion along with the flexing or blending. Okay. Now, there are different factors which affect the abrasion. Okay. First factor is the fiber type. Now, a fiber a strong fiber with higher elasticity will have higher strength, higher breaking energy, higher work of rupture, will have higher abrasion test. Okay. So, high elongation, high elastic recovery, higher work of rupture are considered to be more important factors. Okay. Now, polynylon. So, it is a very common experience, the nylon socks are actually popular. It is basically due to the fact nylon has got very high elastic recovery, high elongation and high work of rupture. So, fabric with made of high fiber with high work of rupture, that means once it is during rubbing, when force is applied, the fiber will get extended, but it will not break, and at the same time due to higher elastic recovery it will come back to its original position. Okay. So, that is how the fiber with high breaking elongation. So, strong fiber and brittle in nature will immediately actually fail, because during abrasion the fiber has to actually absorb some energy. So, higher work of rupture will have higher abrasion strength. Then blending. So, blending of nylon or polyester with wool or cotton improve the abrasion resistance. So, wool, if we use 100% wool in socks, the due to abrasion with the shoe or with the skin, mainly with the shoe, it will immediately form holes. But if we blend the wool with nylon, nylon will take the load and it will take the elastic recovery, and the life, the abrasion resistance will increase. Now, the longer fiber. So, longer fiber will have the for same type of fiber, if the fiber is longer, suppose this is polyester, one is made of small fiber, smaller polyester fiber, another is made of long fiber. So, the small fiber during abrasion will have tendency to come out from the structure, and long fiber will remain in the structure, and the yarn will be intact even after, because the fibers are not coming out. So, fiber length. So, longer fiber into the fabric, better abrasion resistance is there, okay, because they are harder to remove from the structure. So, it will not come out. Once the fiber starts coming out, that means the yarn will fail. Next is the fiber diameter. Now, fiber diameter plays a role in two opposite way. If the fiber diameter, suppose a fiber, this is a fiber with a fine fiber, and this yarn is made of a fiber with coarse fiber, and here it is a fine fiber, A with fine, B with coarse. Now, fine fiber during rubbing it will immediately break, because of its strength it will immediately break, but coarse fiber will not break easily. So, that means the fine fiber will have low abrasion resistance and coarse fiber will have high abrasion resistance. This will have high abrasion resistance, but if we keep on increasing the linear density of fiber, if we are making the fiber very coarse. Okay. Now, we are making a fiber yarn with a very coarse fiber. This is one fiber. Okay. This is fine, this is moderately fine, and then it is a very coarse. Now, if we are making a yarn with very coarse fiber, what will happen? Here number of fibers in the cross section will be less. So, fiber to fiber cohesion will be less, specific surface area of the fiber will be less. So, this fiber will have tendency to come out easily, because the holding power will reduce. That means, if we compare, this is the linear density of fiber and this is the abrasion resistance. That means, initially with the increase in linear density, the abrasion resistance will increase, then after reaching certain optimum time again it will drop. So, the reasons are explained here. Okay. That is why. So, fiber diameter also plays an important role here. Lower fiber diameter, that means chances of fiber damage is there. So, lower abrasion resistance, and for higher fiber diameter, less number of fibers in the cross section. So, again less the few fibers, if it comes out from the structure, that means the yarn will actually fail. So, because less number of fibers are there in the yarn cross section. Next is the yarn twist. Now, yarn twist also plays an important role in the abrasion. Now, suppose we have two yarns, yarn 1, yarn A with low twisted, same fiber with low twist, okay, and another yarn 2 with high twist. So, as it is high twisted yarn, the diameter has reduced, okay. That means, the yarn has become very compact, and this fiber, as it is low twisted, during rubbing the surface fiber will have tendency to come out, okay. This will come out from the structure, but here as it is compact, this will not come out easily. So, that means, if we again draw the curve twist versus abrasion resistance, with the increase in twist, the abrasion resistance increases. Okay. That is the phenomena, because here the fibers will not come out from the structure and the structure will be intact, okay, B. Now, another case, suppose we increase the twist further, we have make it very compact, made it very compact. Now, the type of twist which we have put here, it is enough for the fiber to retain the fiber on this in this structure, but if we still increase further, that means, the when we are rubbing the this yarn, that means, there will be few slight movement of yarn due to the rubbing against another surface, there will be movement of yarn. That movement will actually absorb some energy. This movement of yarn by fibers will absorb some energy, that means, it will not actually rub the this fabric surface too much because of the movement of this yarn fibers, and this, that is why here although it is coming out, but it will absorb some energy, but very compact fabric, very compact high twisted, here the fiber individual fibers are very rigidly held. So, whatever abrasion is there, this will abrade the surface fiber too much, okay, because there will not be any relative motion of the fibers, okay, relative motion of fiber. So, if the fabric is made of very high twisted yarn, then also you will see a drop in abrasion strength. Okay. So, twist, so optimum twist is required. So, optimum twist increases the abrasion resistance. Low twisted fiber can come out easily, and at high twist level more abrasion due to stiffer yarn. So, we need optimum twist. Okay. Now, fabric structure, again a fabric with loose structure, same as the twist here, that fabric made of loose structure will have tendency to absorb the abrasion energy. During abrasion, though if the surface yarns move past each other, then the fabric will have higher abrasion resistance. But if we have a very compact fabric structure, then the abrasion resistance will be less. So, that is why for same EPI, PPI and same yarn, if we have two fabrics, one is say plain woven fabric, another is say satin. Satin, due to its loose structure, it will have higher abrasion resistance, because it will actually absorb few energy due to the relative movement of yarns. So, if one set of yarn is predominantly on the, another way is that suppose we are making say warp faced or wave faced, so satin or something. So, that predominantly one set of yarn, if it is on the surface, that actually total abrasion energy will be actually shared by that particular set of yarn, and that is why that particular set will wear out most. Relative mobility, as I have mentioned, of floats help in absorbing the abrasive stress. So, fabric with a loose structure will have higher abrasion resistance. Now, coming to the factors which affect the test result. So, if we change one of the factors, that will change the test result. So, the study is that the type of abrasion, if we as I have mentioned three types of abrasion, it's whether it is a plain abrasion, plain or flat abrasion, flex type abrasion, edge type abrasion or combination. So, that will actually decide the test result. So, that is why for any abrasion test we cannot simply tell that okay, this is the abrasion cycle, or we cannot tell, we have to mention the first thing that what type of abrasion it was, and type of abrasion we have to mention. So, whether it is a standard fabric or steel plate or abrasive paper or stone, that we have to specify. So, the severity of abrasion will result lower abrasion cycle. Pressure, so at high pressure means higher level of abrasion. So, that means fabrics will have greater contact. So, that will result high abrasion. Speed of abrasion is also important because of the rise in temperature. So, at higher level, at higher speed, the temperature will increase, particularly in thermoplastic fiber, that will affect the test result. And tension, this is also important. If the fabric sample is put under high tension, that means there will not be relative movement and the abrasion will be very high. But the fabric, if it is a loose, under loose condition, then there will be relative motion and that will result higher abrasion cycle before it breaks. And direction, if it is unidirectional, then the same set of threads will get abraded repeatedly, and if it is multidirectional, then the abrasion type will be entirely different. So, we have to mention what type of abrasion we are trying to do. Now, the method of assessment. So, there are two approaches. One is abrade the sample up to the predetermined end point, that means, and suppose one hole is forming. So, up to that point, then we record the number of cycle required to reach that point. That is one way of looking at, and another is that abrade for a set time or number of cycle. So, that we have actually we have set time, say for 1 hour we will abrade, or for say 1000 cycle we abrade, then assess the characteristics of the fabric, some of the like appearance, loss in mass, change in thickness, loss in strength, and compare with the standard unabraded fabric. So, percentage change we can do. So, this two approaches we can actually perform. Now, the methods are, there are several methods. One is the Martindale abrasion tester, where 4 specimens of 38 millimeter diameter are mounted on specimen holder, and the sample is abraded against standard abradant under standard load, and a complex motion is given. So, which is actually superimposition of two simple harmonic motion at right angle. That type of motion is given to the specimen holder. So, this is the picture of Martindale abrasion resistance tester, where there are 4 such holders are there, and at the bottom, as we have mentioned earlier, the standard abradant cloth are placed, and then the specimen holder holds the specimen here sample, and the standard load is kept here. Okay. Standard load is placed, and then the machine instrument started, and this holder, this moves at complex, makes a complex motion this plate, and there will be some movement. Okay. And the assessment of test result is number of cycles are noted when 2 threads are broken. Now, here what we do, we have to first test the number of cycles, we have to note when 2 threads are broken. We must stop the test in between, just to see that whether the breakage starts or not, and the specimen is examined at suitable interval. So, we have to examine, because there should not be any more breakages, and if we know the likely failure, then we can start inspection from the 60% of that value. Suppose we know if there will be 1000 cycle required normally for 2 breakages. So, we will start with the 600 cycle and keep actually noting the, keep observing the condition of the fabric. Now, assessment of test result, normally in Martindale abrasion tester we measure the loss in mass, say in milligram per 1000 cycle. So, how do we measure? So, where what we do, total 8 specimens are taken, 2 specimens are abraded up to 2 thread breakage, that is their extreme end point. Okay. So, that we know that, and we note down the number. Okay. We do note down the number of the cycles required. Other pairs are abraded 25%, 50% and 75% of the above, means suppose 2 threads are broken after 1000 cycle. Okay. Then we will test up to 250 cycle, 500 cycle and 750 cycle. So, there are 4 pairs. So, other 3 pairs are 2 specimens for 250 cycle, other 2 specimens for 500 cycle, and third pair will be for 750 cycle. So, we have got 4 different specimens, and then average loss in mass can be measured. So, from each specimen we can measure the average loss in mass. So, we have got 4 specimens. So, average loss in mass we have got, and we can plot the curve. Then we can extrapolate to get the loss in mass in milligram per 1000 rubbing cycle. So, that will give a result. Okay. And for hosiery fabric, due to the extensibility and to make it the severity of the test, because in the hosiery fabric the fabrics are actually, it is a twisted, sorry, it is a knitted fabric, there will be relative movement of the yarns. So, that is why the fabric will show the higher abrasion cycle. That is to reduce the abrasion cycle, we insert a flattened rubber ball, is pushed through the same sample holder, and it is tightened, thus stretching it. We have to stretch the sample, so that we can get certain result, okay, and tested under 200 kPa, it is a higher pressure. So, till the holes appear. Otherwise, if we test as per the woven fabric specification, the testing cycle will be very high because of the lateral movement. Another measurement technique is it is called accelerator test, where the fabric specimen is driven by a rotor inside a circular chamber, okay, lined with a abrasive cloth. Okay. So, this chamber, it is lined with an abrasive cloth. So, this is the rotor, and after that we cut the sample. Okay, the sample suffers abrasion by rubbing against itself, as well as the liner abrasion liner is there, and we put the loose fabric specimen, and then it is covered and rotor is started. So, then fabric is tumbled and rubbed against itself, okay, and with the liner. The evaluation method is that by weight loss. So, as earlier we can also measure here the weight loss and per a particular time, and loss in grab strength. So, we can test the grab strength of the fabric. I will just explain. The weight loss is by the size of the sample depends on the grams per square meter. So, if it is higher mass per square meter, that means the quantity of material will be more. So, we can reduce the size of the sample. After abrasion, the specimen is taken out, and any loose debris or loose fibers are removed and take the mass. So, we take out all these peels and any loose fiber, any hairs. So, this we will take out and take the mass, and we will measure the weight loss of the fabric. Percentage loss is calculated, and next method is loss in grab strength, where the specimen 100 millimeter by 300 millimeter specimen is actually it is cut 10 centimeter by 30 centimeter. This is the 30 centimeter by 10 centimeter, this is the specimen. Now, we cut this fabric into 2 equal parts. So, that means the specimens are it is 150 by 100. So, specimen size becomes 100 millimeter by 150 millimeter. Now, we keep one specimen as standard specimen. Okay. This is the standard specimen, we keep separately reference specimen. Another is that which for abrasion testing, this is for original for grab test. This specimen is kept for as a reference, and this specimen we use for rubbing. Now, before rubbing we have to actually prepare this sample. How to prepare? What we do? We fold 50 millimeter from this side, this is 150 and by 10. Okay. So, 150 by 100, from this side we fold this side by 50 millimeter. So, 50 millimeter is folded. So, effectively the fabric size will be and folded and stitched. Okay. So, that we make. So, this is the fabric. So, this is say 150 millimeter and this is 100. Okay. Now, what we do, we take 50 millimeter here and we fold it. So, effectively the fabric is 100 millimeter by 100 and then this fold portion we stitch somewhere, keep it, and this fabric, this specimen where its edge is there, okay, folded edge is there, this specimen we place into the testing chamber and where this specimen is being tested and rubbed against the edge. Okay. So, this accelerate, then after certain cycle we take out this fabric and this is this fabric which fold its we have taken out, we have removed the stitch and then we test this fabric for the graft strength, and this is the fabric which is being rubbed and this graft strength, and another fabric which has been kept separately, this reference sample, and that we test and we compare the result, we compare the loss in graft strength of the this fabrics. So, that gives the indication of the edge type of abrasion. Okay. So, folded edge is abraded, the abrasion is after abrasion the stitch is removed and the graft strength is measured compared with the sample without abrasion. So, then we can calculate the percentage loss in abrasion. So, these are the ways we can evaluate the abrasion. So, here in this session we have discussed various aspects of peeling and abrasion. We have discussed the various factors which affect the test result. Here we have discussed how to control the peeling resistance or abrasion resistance. Okay. And we will finish this session here, and then in the next session we will start with the new topic. Till then, thank you.